Hello everyone, I am Varun and our next topic is logistic regression. And first we will start with our introduction of logistic regression. What we will learn in this, what is logistic regression and why not linear regression for classification and its function and how it works and real life example and the implementation of the code. So here we start introduction. Logistic regression is one of the most and important and widely used classification algorithms in machine learning. Despite its name, it is not used for regression problem. It is used when the output is categorical, most commonly binary 0 or 1. What is and now we will see what is logistic regression. Logistic regression is a supervised machine learning algorithm used for classification, mainly binary classification, and as we have seen example, binary, most commonly binary 0 1. Why not linear regression for classification? Linear regression gives output from minus infinity to plus infinity, but in classification we need probabilities 0 to 1. We need a clear decision boundaries. That's why logistic regression use sigmoid function to convert values into probabilities. And it is here is our example graph example, and it is the title logistic regression, and this axis is y-axis and sigmoid function where it converts into probability. Here is the measurement, and category 1 observation can be noted as that orange color, and category 2 observation can be categorized as red green blue, and it is measured and to convert the function values into probabilities. And here's the graph goes from here to here. And sigmoid logistic function, the core of logistic regression is sigmoid function where z equal to b naught plus b1 x. Output is always between 0 and 1, and interpretation is here for class 1 and class 0. Greater than output is greater than equal to 0.5 and less than 0.5. How logistic regression works step by step. Take input features x, multiply with weights, add bias, pass result through sigmoid, convert probability into class 0 or 1 as we have discussed here. 0 or 1 means our most commonly binary. And now we will talk about our example, as we have taken dog versus not dog, as we have taken that in confusion matrix also, and we are denoting 1 as dog and 0 as not dog. Logistic regression predicts probability of the image being a dog. Now we will see in the code an explanation of it, and we are importing the required libraries for logistic regression. Import numpy as np for the calculation, and import matplot pip lot as plt for the plotting, for the graph plotting from sklearn.linear model code logistic. Now here we are importing logistic regression or generating the logistic regression from sklearn linear model, and here it is our input variable and output label. And in this model equal to logistic regression means we are creating or generating the logistic model regression, and model dot fit xy means we have trained the model, and here it is our output is given from running the code. And y underscore prediction equal to model dot predicts print y prediction. Here it has predicted the here it is the prediction of here it is the model has predicted of dog and not dog, like we have discussed here. We are considering 1 as dog and 0 as not dog. And in the fifth cell plot dot scatter, plot plt dot scatter, the color blue, and plt dot plot x model predict, color equal to red, plot x label and y label, title will show, plot title will show, it will show the output by representing a graph plotting. And plot dot title means we have given the name here, data, and y level is y axis, we have probability of passing, and our studies means this. Plot dot scatter. Okay, now in this graph, as we have discussed earlier, it is the sigmoid function which is converted in probability, and that blue one is the first category observation, and it is the second category of observation, and it is the best line logistic regression. And each code is explained step-by-step implementation of logistic regression from data preparation to model training, prediction, and visualization.